So talking about horizontal asymptotes, we're going to split this up into two chunks. So first we're going to look at when the denominator's degree is bigger than the degree of the numerator. Okay, so this example is the function f of x equals 1 over x that we've been talking about for the last couple of days. And notice that as x gets bigger and bigger and bigger, this fraction is dividing by a larger and larger number. And when the bottom of a fraction gets really big, then the fraction is going to equal a really small number. Imagine cutting a cake. Okay, if we cut a cake into 10 pieces so we can share it with 10 friends, we're each going to get a tenth of a cake. That's 10% of a cake, basically, right? Well, if I have 100 friends to share the cake with, I'm now going to need 100 pieces. Those pieces are going to be smaller. They're only going to be 1%. And then the more friends I'm trying to share that cake with, the more pieces I'm going to need and the smaller they're going to end up being. So as a fraction's denominator increases, the fraction is going to get smaller and smaller and smaller. And so as they get smaller and smaller, they're going to get closer and closer to zero. And so what's happening is this graph here, as we get bigger and bigger x values, the graph's approaching zero in both directions. So this works for negative numbers as well. Okay, now let's look at another example where the denominator is something different. So even though this isn't just 1 over x, the same thing happens. The denominator of this fraction is getting bigger and bigger and bigger, and so this fraction is equaling a smaller and smaller number. And so as the x values that we're putting in get bigger, the outputs are going to get smaller in each direction. So that gives us a horizontal asymptote of y equals 0 in both these cases. Okay, and here you can play around and you can make the denominator anything you want. And you can see that it really doesn't matter what I make it, as long as the degree of the bottom is bigger than 0, I'm going to have a horizontal asymptote at y equals 0 because this graph is going to be getting smaller and smaller as those x values increase, making the denominator bigger and bigger. So to summarize, as x gets bigger, it's going up and up and up, the denominator is also going to get bigger. It's going to go up and up and up. And that is going to make the entire function, f of x, get smaller and smaller because a fraction is smaller when the denominator is much, much bigger than the numerator. Okay, so that's what's driving these horizontal asymptotes to be y equals 0. Okay, now even when we have a numerator that's not 1, as long as the denominator's degree is more than the degree of the numerator, it's still going to grow faster. Okay, remember, the higher the degree of a polynomial, the faster it grows. So on the bottom here, you have a second degree polynomial. On the top, you have a first degree polynomial. Well, this second degree polynomial is going to be growing faster than the first degree polynomial. So look at these outputs here. As my x increases, my output for the numerator is increasing, but the output for the denominator is increasing even faster. And so this fraction is still going to be driven down to 0. And so my horizontal asymptote is going to be y equals 0 anytime the denominator's degree is bigger than the degree of the numerator. So here you can play around and put pretty much anything you want. If you put in something with a degree higher in the numerator than the denominator, though, it'll tell you you did something wrong. So let's make the degree of the numerator bigger. Let's go with degree 7 polynomial. And yeah, you got some funky stuff going on here, but it's still got a horizontal asymptote at y equals 0 because this bottom number is going to be getting bigger faster than the top number, which will drive the fraction to 0.